All right, here we go. Now we're ready to start solving equations with trig functions in them. So we're going to start with some real basic stuff here and some things that we're going to kind of look for as we go through. And then we're going to do a bunch of examples, and there will be some steps in there for you to try and follow as well. They're going to be kind of general steps because these equations are going to follow a whole gamut of things. So let's just consider the equation cosine x is equal to a half. Now, using our quarter circle, we can go back and try and find where that is, but that's only one value. What we know from the graph of cosine, that I really have very messily sketched out here, is that there are a lot of places where that y value is a half. And so there are, just on my graph here, I have 1, 2, 3 different places where cosine is going to be equal to a half. So we're going to have to really first pay attention to the directions that we're working with. So you have 3 possibilities here really for the directions. First, you can be looking for solutions that are just between 0 and 2 pi. That's going to be our first trip around the unit circle, but it's going to be in radians. Okay, now so you have to be really careful. You want your answers in the right mode. So radians or degrees, which is number 2, between 0 degrees and 360 degrees. And then finally, number 3 here is going to be all solutions. And basically the way we're going to pull this off is we're going to add 2k pi to all of our solutions that we find. Because what happens is, because these trig functions are periodic, k here is just an integer. So what we're doing is we're adding multiples of the period. Because wherever you have one solution, if you add that period on again, you will get a second solution. And so that's kind of where we're going to head. And so we're going to do some examples, see some ways that this is going to work. And yeah, it'll be fun. All right, so here we go. We have some steps here. We have an example, which is definitely taking up my entire board. So hopefully you can read it. I'll try and talk my way through it, and hopefully it works. So the basic steps for solving a trig equation. First, get the trig function all by itself. Okay, so just like on regular algebra problems, you try and get the x by itself or the y or whatever your variable might be. Here we're going to want to try and get our trig function all by its lonesome self. Once that happens, we can move into the next 2 steps. Okay, so step 2 then is to either use our quarter circle from back in section 5.2 to come up with some exact answers, or we can use inverse trig. Okay, and so some of you are going to be really happy with the inverse trig option, which, by the way, we'll talk about that here in a minute. And then, are there any other solutions? Because trig functions are going to have a lot of solutions. Even just going around that circle one time is going to provide us potentially with a lot of solutions. So those are our 3 basic steps. Kind of keep those in mind. I suggest you write them down on a piece of paper for when I clear this board off and we do some more examples. But anyway, here's our first example. Find all exact solutions for 4 cosine cubed x is equal to 3 cosine, oops, I forgot my x. There we go, x. All right, so this is our first equation, and it's a little bit messy. So here's what I see. I want the cosine all by itself. Here's what you can't do. You cannot divide both sides by cosine x, as appealing as that might be. If you do, you're going to throw away a whole bunch of solutions. So don't do that. So instead, you'll notice that I subtracted the 3 cosine x, and I promise this is a 0. Because that gets me 0. And then I factored it. Okay, so instead of dividing by cosine x, which gets rid of that cosine, I just factor it out. So I have cosine x times 4 cosine, now it's squared x, and minus 3, right? I pulled out one of those cosine x's. We're really treating cosine x here just like we would a variable, right? If this were x cubed and an x, you could pull the x out of it. Here we're pulling out a cosine. The good news is once we do that, we have it in factored form, which will allow us to split this equation up. Because we have 2 things that multiply together to be 0, we can pull them apart. So we do. We get cosine x is equal to 0, and we get 4 cosine squared x minus 3 is equal to 0. So let's follow the cosine x equal to 0 through first. We know a bit about cosine. In particular, we should know that it is equal to 0 at the top and the bottom of the circle. Okay, those are where that's going to happen. And so if you know your angles in radians, the top one is pi over 2, and the bottom one is 3 pi over 2. Now, since we want all exact solutions, we have to have the pi over 2 and 3 pi over 2. We can't have a decimal there because it wants exact. But it wants them all. So I've added the period for cosine on, right? With that k in the middle that we talked about just a minute ago. So we've added all multiples of the period to it. And that means that every time every time you come back around the circle and get to either the top or the bottom, you get another solution. All right, so that's the cosine x equal to 0. Next, we have the messier one, and it really is a lot messier. So let me get these dots off of my circle because we're going to need that to be clear here in just a second. There we go. All right, so 4 cosine squared x. So this time, I'm still going to try and get that cosine by itself. So I add the 3, and I divide by 4, and that gets me to cosine squared x is equal to 3/4. Now, just like with x squared, we can take a square root of this. And when we do, remember you get a plus or minus, because you always get a plus or minus when you solve by taking a square root. And I'll point out that I kind of skipped through here, but the square root of 4 is 2. That's why the denominator isn't part of the radical. Okay, we don't, square root of 3 is ugly, but the square root of 4 is really nice. It's just 2. So we need to know where cosine is equal to plus or minus the square root of 3 over 2. And if you go back to your circle, the first place where that happens is right here, and it's at pi over 6. Okay, that's the angle that we're actually looking at here. I'm hoping that you can see that. But what happens then is that anywhere that cosine has pi over 6 as a reference angle will give us one of these two things, either a positive or a negative square root of 3 over 2. Because remember, reference angles have the exact same cosine values as the original angle. So I know that there is another angle here and here and here. All 4 of those have a reference angle of pi over 6. So if you follow along and go around the circle, we had pi over 6, and I added my 2k pi to make it all of them. Then I have 5 pi over 6. That's going to be this next one, and so you might have to work a little bit to try and figure that one out. But, take a look at it. And plus 2k pi. Then the one down here just past pi is 7 pi over 6 and plus 2k pi. And then the last one is all the way almost to 2 pi, 11 pi over 6 plus 2k pi. And so that's pretty messy. That's about as messy as these will get for you. And notice we have, even ignoring for a second the fact that we have the 2k pi's giving us infinite solutions, we had 1, 2, 3, 4, 5, 6 different solution sets here happening. And so that's, there's a lot of possible solutions here. You really got to watch out for those. All right, we'll try some more, but I think they're going to be on the next video.